So my name is Jeff. I worked for NASA for 5 years. I designed space missions and space technology. And now I work here in the on the East Coast in the DC area. I have my own company and I do lots of different stuff, especially in space. And I like to talk to kids and students because people did that for me when I was a kid, and it got me really excited, and it's the reason I have the interesting career that I have now. So, great. So, we are gathered here today to talk about the space race. And I think this is, I hope you'll find this is one of the more interesting parts of history, because it actually has a lot of really exciting components, from war to culture, technology, and it is awfully early in the morning, so I'm going to do my best to make this as exciting as possible. And one thing I think you'll find is interesting is that it's not just about the 60s. It goes back farther than that, and it connects directly to the present day and things that are happening this week. So, I'll just get right into it. So the space race, what that typically refers to is a period between 1957 and 1969, during which the Soviet Union and the United States were in a race to put people on the moon for the first time. And there's a lot of questions to ask about why that happened and why that is relevant now. And we'll get to that. But first, I want to talk about the setting of 1957 and why this was a big deal then. So World War II had ended about 10 or 12 years earlier, but the world was still in a pretty active state of conflict with the Korean War and the emergence of the Soviet Union from the ashes of World War II, and the League of Nations, the post-war global effort to avoid conflict like that in the future. But what had also happened that was really not well appreciated is that the technological advancements of World War II set the stage for basically the modern world as we know it, all of the technologies we use today. So the mid-50s, there's a lot of people today who would take us back to the social era of the 1950s. We're not going to talk about that. But what was happening in the political era of the 1950s was, after most of the world was nearly burned to the ground during World War II, there were a lot of people who felt pretty strongly about that and wanted to either rebuild their chosen path or, in the U.S.'s case, maintain superpower status. And so the Soviet Union and the U.S., at least, if not other major countries, had massive research and development activities going on because of World War II, basically weapons development and intelligence activities. And one of those was the conversion of World War II era missiles into space rockets. And we'll get to that in a minute, but I wanted to set the stage there because we have to go back a little farther in time first to really talk about how we went from setting European cities on fire with missiles to launching stuff into space. So it really goes back. You could think of it going back to the 19-teens. Actually, during World War I, there was a researcher in Russia who really was the first person to put down on paper the math that you really needed to figure out in order to put something in orbit. And he died in 1934, so he never saw it. But he was really the first person that realized, with the fuels and the technology of the early 20th century, that in principle, it might be possible to actually put something in orbit. So before we talk any further about the history, I want to talk about what orbit means, because it's not always obvious. So an orbit typically refers to an object in free fall around another object. So that's like the Earth going around the sun, the moon going around the Earth. Those two things happened because of events billions of years ago, but in the last 100 years, it became possible for us to put things in orbit. And what that basically means is you throw something straight up in the air and a little bit sideways, hard enough that as it falls, which everything does, it never actually hits the ground. So it falls around the Earth forever, more or less. So that's what we mean by an orbit. And there's a lot more to talk about there, but the basic point is that if you think about that capability in the context of the early 20th century, it was around the early days of aviation. Aircraft were first being used in World War I to deliver mail in the U.S. and to drop crude bombs in Europe. If you think about that in 1916, and suddenly somebody says, "Hey, we could actually put something in space and have it circle the Earth indefinitely," that was a really big deal. The technology didn't catch up for 40 years, but by the 1950s, it was possible. And towards the end of World War II, as you may know, there was a huge exodus during and towards the end of World War II, there was a huge exodus of scientific talent from Eastern Europe, Germany in particular. A lot of scientists came to the U.S. as refugees, or more directly to work on the weapons programs, in the case of Einstein and some others. But a lot of them went east also to Russia, and Russia certainly had its own internal talent. So what that meant was that towards the end of World War II, we were both sides were getting really good at building missiles, and then the war ended, and there really wasn't anything to bomb and set on fire anymore. Certainly in the Korean War buildup, there was a lot of posturing and weapons placement, but then both sides realized we could put something in space, and what would we do with it? Before I go any further, am I at the right energy level? Is this interesting, exciting to you guys? I'm glad, because it really is a fascinating part of history, and it's recent enough you can go find people and talk to who are still alive who saw this. So that's not going to be true for much longer. So we're back up to 1957, and something very important happened in 1957 that I think if you talk to anyone older than 70, they'll remember it. The Soviet Union successfully launched the first satellite into Earth orbit, and it was about the size of a basketball. It was called Sputnik. It was like a metal basketball with little antennas, and all it did was beep, 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 and that was only to communicate to the Soviet operators that it was still there and that it was working. And now that is about as quaint as as a white picket fence. But at the time, it was as terrifying of a capability as anyone could imagine. I'm trying to think of a modern capability that would be as scary as that. Okay, maybe something like a cloaking device. Imagine if in the newspaper tomorrow you saw, Russia has invisible nuclear weapons positioned over every major city. It was that scary. It was that scary at the time because most people had not really spent any time thinking about space, or certainly had learned about it. Maybe they learned about the planets a little bit. I don't even know if that was part of the regular curriculum in the 50s. But certainly the idea of a Soviet satellite orbiting the Earth, possibly going over your house, was terrifying. And remember, this was in the early days of jet aviation, so most people probably had not flown on a plane. If they had, they hadn't gone as high as passenger airlines go today, where you can't even see the ground, really. So the sky and what was above it was a total terrifying mystery to most people. So that was Sputnik in 1957. And that came as a relatively complete surprise to the United States. And that set in motion some things that really are still directly in effect today. I mean, it takes, we'll get there. So two things happened immediately after that by the United States government. The government formed two different agencies. NASA was formed in 1957, and the U.S. government realizes that it needs to formalize efforts to reach outer space, and in particular, it needs to have an organized response to this technological surprise by the Soviet Union. And if you ever heard of DARPA, the Defense Advanced Research Projects Agency, has anyone heard of DARPA? No? Okay, you should look them up. They're pretty cool. They invented the internet, among other things. So, I'm just old enough to remember a time before the internet was available, and I don't remember what I did all day. I really don't. I had a computer too, but I can't remember what I did with it. It's hard to imagine a computer without the internet, but that was the thing. Anyway, so 1957. So the U.S. government creates DARPA as a part of the DoD, and its goal is to, in the following words, prevents technological surprise. So what that means is that that agency's goal would be to never again have the U.S. government be so completely stunned and surprised by the emergence of a technological capability by an adversary. And that agency has done all kinds of interesting things. I'm trying to get some projects off the ground with them. It's really hard, but that's DARPA, and we might talk more about it. But it's important to note that DARPA and NASA were created in response to the same event. So NASA was created also in 1957, and it was sort of cobbled together from an agency that existed prior called NACA, N-A-C-A, the National Aerospace Committee something administration, that had been in place since World War I. And that agency I'm not even sure it was an agency. Oh, committee, that's what the C stands for. That committee had been set up to coordinate aviation work in the U.S. During World War I or shortly before. Not that important, but point is NASA as a space agency was created in 1957. And that was significant because at the time, it was unusual for a nation to have a civil space agency. Now, what does that mean, civil? So one way to look at the different divisions of the federal government are civil versus military. The military has a huge budget, and it also has a lot of sub-agencies. So, for example, the military has a healthcare agency, has a Veterans Administration. The point is that in the U.S., the civil space agency was NASA, meaning it does not technically work for the military, and it is not subject to the same kinds of classification and secrecy. In a lot of other nations that have a space program, that's not the case. The entire space program is in the military, or at least that was true for many decades. So that was a bit different on the part of the U.S. at that time. Now, so what was this agency set out to do? So the first thing it set out to do was to establish capabilities to get things into orbit. As you can imagine, that's the first step to getting anything into space, is putting things there. But so there were some missions in the late 1950s. There was the first launch of an American into space. I think that was 59. He orbited the Earth a few times. It's important to keep in mind that the tensions at the time. The Soviet Union was this totally mysterious adversary, perhaps not to the upper echelons of the federal government, but to most people. And so there was literally a race to put a person in space for the first time. And if you think about that compared to today, the agencies of today would never in a million years take the risks of what was done at the time. But at the time, and again, I wasn't alive then. I've read and heard about it and talked to people. It seems like there was just a very different attitude towards risk and conflict then. So the first human being in space was Yuri Gagarin. He was a Soviet pilot. I think that was 58. Point is, it was before the U.S. And a small side note, Yuri Gagarin was, I think, like 5'1". He was a test pilot, and he went into space. He was the first human being in space, and then he later died in a plane crash. There's some ironies in history that are just unbelievable, and he's one of them. So that was sad, but he did achieve the relatively impressive feat of being the first human being in space. So at this point, the U.S. had been beaten twice to space, first by a little machine and second by a person. So the U.S. was really not any less combative and confrontational, competitive then than it is now. So you can imagine there was a significant urge and desire to top that, basically, to top that first human in space. And what that turned out to be was a challenge issued in 1961 by John F. Kennedy to put people on the moon by the end of the decade and bring them back. Now, I want to spend a lot of time on this because it's important to understand just how stupendous of a challenge that was at the time. It would be harder to do that. That was harder than it would be to put humans on Mars in 10 years today. It was just a staggeringly complex and difficult challenge. And if you read biographies about JFK, which I'm sure you will all do at the end of this call, you'll go out and get them all and spend the next 3 weeks reading them. It seems that John F. Kennedy was so ignorant about science. I mean, kindergarten level science, maybe not even that. He did not even remotely understand the challenge, that the scope of the challenge that he had issued. And there's some people now, some historians, that think if he had had even a third grader's science education, he would never have said, let's go to the moon, because he would have understood just how ridiculously difficult it was. In the past, I've tried to think of metaphors for how hard it is. You can imagine 5,000 years ago, the first Polynesian person who said, I'm going to take this canoe and go find islands in the middle of the Pacific. That might have been easier than putting people on the moon in 1969. Rowing a little boat from Tahiti to Hawaii might have been easier, relatively. It's really hard to understand just how stupendous of a challenge that was. And yet he made it. And as you know, it happened. But the story of how it got there is just an absurd bit of history, and we'll go through it. So the Soviet Union got wind of this and said, okay, we're going to do it. And that began one of the most incredible, unbelievable, ridiculous, ambitious periods of human history. At the time, we certainly knew a lot about the moon. We knew where it was. We knew how it moved. We had on paper, we had the science down. What the engineering was completely new. And let me take a moment to separate science and engineering, perhaps for some of you who might be considering those fields. Science is about knowledge of things, how things work, why things work. Engineering is about using that knowledge to build something, to do something. So, in the 17th century, Kepler developed the laws of orbital dynamics. So he is the first human being to understand how and why the planets move. So until then, even if you had 21st century engineering, it would have been impossible to go to the moon because you didn't know where it was. So Kepler developed that in the 16th or 17th century. It took 300 years for the engineering to catch up, meaning for it to become possible for human beings to build a machine that could actually do it. So that's one of the ways of thinking about the difference between science and engineering. You could talk about this for years, obviously, but the point is that the science of how to get to the moon had been known for a long time, but that's very different than sitting down with a pencil and paper or an extremely basic computer and saying, okay, now we're going to build a machine to do it. So you can imagine if you were a scientist in 1961, and on that morning you went to work and who knows what you did, but then at some time in the middle of the day, the president got on the TV and said, we're going to send people to the moon. You can imagine you might have had a really hard afternoon because suddenly you were given the most difficult job in human history. And, but those guys in their pocket protectors and short sleeve button down shirts and ties figured out how to do it. And what they did was basically they created a plan of, which I think is still the best way to get large projects done, is you go step by step. So you might have heard about Apollo 11. Apollo 11 was the first mission to land people on the moon. Well, what was Apollo 10? That was the first mission to go around the moon. What was Apollo 9? And so on. So what they did was set up a series of missions that basically performed each step of the process of going to the moon, one at a time, and used each mission to build the next one. So Apollo 1 was a tragedy, but we'll talk about that. Apollo 1 was putting a crew vehicle in space. And that's it, and getting it back. So we'll talk about Apollo 1, actually, not just because it was the first step, but because it was a tragedy that added to the political flames of the time, that fed the flames. So in Apollo 1, the three astronauts died. And they died because on the launch pad there was a fire in their crew capsule, and they could not escape. And the reason they could not escape was that the door had been designed in such a way that it could not be opened from the inside, especially if the air pressure on the inside was higher than on the outside. And there was some circuit breaker problem, and a fire started. And because the crew was going into space, there was more oxygen than in the regular atmosphere in that capsule. And that, as you know, accelerated the spreading of the fire, and the first three astronauts died. Burned to death on the launch pad in the crew vehicle in 1961. And as you can imagine, that was a really serious blow, not just to the technological progress of Apollo, but to the morale of the nation and the program. And there were a lot of calls to end the program right there. People saying, well, if we can't even do this, we can't possibly get to the moon. Those people still exist today. They're the people who want to cut science budgets and basically don't understand how science works and how the progress of human knowledge happens. I'll try to avoid editorializing further on that point. But there were also people in 1961 who said, what would those three guys want? Would they want their lives to have been in vain? Would they want everyone else to give up? And I think that this would never happen today, but in a great display of leadership, they continued. The Apollo program continued, and eventually it was successful in 1969 with the landing of 3 people on the moon and bringing them back. And so of course, John F. Kennedy was assassinated, I think, in 1963 or 4. So you had, then there were still 5 or 6 years before the moon landing. So you really had 2 or 3 remarkable events that happened in a sequence that really made the moon landing possible. Nobody was going to cancel Apollo after JFK was assassinated because that was his vision. There's historians who think that if he had not been assassinated, Apollo would have been canceled. Apollo cost a lot of money at the time. It cost about 5% of the total federal budget, which is a huge amount of money, even at the time when the federal budget was a lot smaller. Today, NASA's budget is 0.5% of the budget. So it is half of 1%. It is 10 times less than it was in the 60s. So it was costing a lot of money, and it wasn't clear whether it was going to work. And so, okay, someone's calling me. I don't have to answer it. Where were we? Right. So there was a lot of pressure to cancel Apollo, but again, because of Kennedy's ignorance and the Apollo 1 fire and then Kennedy's assassination, there was no way that Apollo was going to be canceled. So much had been put into it. And not having been there, I can't really speak to that in much deeper detail, but it's really the point is it's much more complicated than just we decided to go to the moon, we went to the moon. There was internal U.S. politics throughout the 60s, and of course there was a lot of other stuff going on in the 60s. And still we triumphed over human nature and physics and nature itself, and we got people on the moon in 1969. The Soviets were also trying. They never succeeded. They did. Oh, let me make a small tangent. So during the 60s, apart from the human side of this project, there were also a lot of robots being sent to the moon. And again, this the way that worked really reflects a big difference between the risk tolerance of that era and today. So, for example, the place I used to work, JPL, the Jet Propulsion Lab in Los Angeles, was tasked with sending various rovers and landers and orbiters to the moon to better understand the surface so that we would know, for example, what can we even land on it? I mean, what if you land on it and you just sink? I mean, we didn't even know that. It took 6 tries to get the first thing on the surface of the moon. The first lander. The first 2 rockets exploded on the pad. The next mission missed the moon completely. The next 2 completely crashed into the moon. And then finally, one of them landed, but the cameras didn't work. And then I think it was the 6th or 7th one, finally landed and the cameras worked. Now, you need to understand how unimaginable that would be today. Now, in the current era, that kind of failure would not be tolerated even in the first case. But every time they failed, they went back to NASA and said, we need more money, we need to do it again. You can imagine after 5 or 6 times, that got pretty old. But again, because so much had been put into it and it was such a critical part of getting set up for the moon landing, for the human moon landing, that they were successful, and eventually they were successful. Now, it's totally reasonable for it to have taken 7 tries because no one had ever done it before, certainly not on that schedule. So that was really the urgency that this was viewed with. Now, the Soviets had also been working on this. They landed several things on the moon. They got a lot of stuff there. They never got people there, and that's because of some history that goes back to World War II again. So if you look up Saturn V on the internet, you'll see a 32-story tall rocket that's just stupendously large and was used to take people to the moon. The reason the rockets had to be so big is that in space, rather on Earth, when you drive somewhere, you don't have to bring all your gas with you to come back home because there's gas stations everywhere. In space, there aren't gas stations, and that creates a really big problem. Basically, if you want to fly all the way to the moon and back, the fuel that you're using in the last 10 miles of that trip, you need to bring with you from the ground. And because fuels and rocket engines weigh a lot, what that means is that the farther you want to go in space, the heavier your rocket gets on the ground, and it gets heavier very fast. So in order to bring back the human beings, the three first moon landing human beings, which returned, who returned in a capsule about the size of a minivan, let's say. So hold that in your head. A minivan, to take a minivan to the moon and back, required a rocket that was 32 stories tall, divided into different sections, which really are not the point of today. But the point is, this is a really big machine to build. Not just in the 60s, even today, that's a very big machine to build. A lot of places for it to go wrong, a lot of ways for it to explode spectacularly before you want it to. And remember, this is a 32-story building full of rocket fuel, basically, that just really wants to explode violently, catastrophically at any moment. So it was an incredible achievement that these things could even be built in the first place and not explode spontaneously, let alone function as designed all the way to the moon and back. So let's see, 17 of these Saturn V rockets were built ultimately, and 14 of them flew, and we'll talk about why that is. The Soviets, so the reason Saturn V, there's a 5 in there, is because there's 5 giant engines on the bottom of the rocket, each of which is like 20 feet wide or something like that. And that was the brainchild of one of the researchers that left Europe during World War II and came to the U.S. And it's a good thing for us he came to the U.S., because if he had gone to the Soviet Union, they might have had that rocket instead of us. And it turned out that the Soviets never actually built a rocket big enough. I'm sorry. They did build a rocket big enough to send people to the moon, but it kept exploding on the launch pad, which is really a drag if you want to go to the moon. These things, imagine a 32-story building full of rocket fuel exploding. I mean, that's a big problem. And in fact, it was such a big problem that the launch site is in Kazakhstan, not even in Russia. Well, I guess that was the Soviet Union at the time. But it's about the most desolate place on Earth, which is, again, a good thing if you have a 32-story building full of rocket fuel that might explode at any minute. So I've never been there, but I know some people who have, and it apparently is just an amazing site. The most desolate place on Earth, and then some of the most advanced technology on Earth right in the middle of it. Anyway, the Soviets never got their giant rocket that far off the ground, and so they couldn't even attempt to put people on the moon. A small side note, they did manage to send a rover to the moon called Lunokhod, Lunokhod. I guess at least that's how you spell it in English. If you look it up, you'll see it looks like a little robot with wheels, and it's a guy in a human being on the ground actually drove it with a joystick. Now imagine, it is the Soviet Union. You're an engineer. It's the 1960s. Everybody knows you're behind compared to the US, and your job is to drive a robot on the moon manually. Imagine the stress of that guy. Well, he pushes the stick. 4 seconds later, he sees something back because it takes a few seconds for light to get to the moon and back. For a control signal to get to the moon and back. And this was not with a very good camera. So I like to take this back to the human side once in a while, because ultimately it's human beings that do all these things, not government agencies. And I guess I just have a lot of sympathy for the people in the Soviet Union for whom failure was maybe not imminent death, but pretty close to it. So yeah, I don't know. Sometimes I think about that person, and I just imagine the pressure he was under, and of course not just him. Getting back to, where were we? Right, getting back to the actual landings themselves. There's a lot more we could talk about in the 60s, but I think we'll go right to July 20th, 1969. People were probably still hungover from Woodstock, and the first two human astronauts land on the moon. And it is a day of celebration that I'm pretty sure I've never seen in my life. I was born in 1982. It was a day of national unity. It was a day of human unity, I suppose, unless you were in the Soviet space program. But again, it was something that really established a sense of leadership from the United States. So the U.S. is in this wonderful position of leadership and power, and you can imagine everyone is very happy. And a few more missions go on, and now it's 1972. Who was president in 1972? Okay, Nixon.
Sorry.
Until very recently, the biggest in presidential history, in my opinion, and for lots and lots of reasons. But to him, the moon landing was nothing more than a political stunt. It was pure politics. It had nothing to do with knowledge or technology or advancement or leadership in any meaningful way, other than an ape.
Oh my God.
And so what he did was he canceled the rest of Apollo. He said, "Oh, we've done it. We beat the Soviets. We don't have to do the rest." And that's why there are 3 Saturn V rockets sitting around the country, fully built, ready to be fueled. Well, not anymore, but at one time they were ready to be fueled and sent to the moon. To me, that was just one of the greatest tragedies of federal government policy ever. And that had several consequences that we're still dealing with today. So until then, NASA was perhaps getting an unfair share of the federal budget. It was getting a lot of money. Like I said, 5%. I think that peaked at 5% in 1967, but still, it was getting a lot of money. There were a lot of people who were saying, why are we still using this money for that? But what it did since then, what it did was it set NASA back to a place where it had to compete for federal money with everybody else. And some people might say, well, that's fair. It's a federal agency. But the problem is that makes it very difficult to make long-term plans that take a long time to do, which things like space exploration. And it also drastically changes the risk tolerance of an agency, because they know that suddenly they are much more accountable for their dollars. Now, again, that is not necessarily a bad thing, but it completely ignores the unique nature of space exploration as something that takes a long time, has very large costs up front, but can yield immeasurable benefits. And so just to bring it to the present, NASA has done a lot of things since then. They've all been a lot smaller than Apollo. And for example, in 1969, after the first moon landing, people were starting to look at a Mars landing. And there were plans that could put people on Mars by 1989, 20 years later. Obviously, that never happened. And that's in large part due to the changing of NASA's posture within the federal government by Nixon. And there's maybe an argument for that to some degree. But what it created was this really strange peak in human history where, for a brief period, we had the capability to send people to the moon, and now we don't. And that's a really weird outcome of that era. To this day, NASA is still struggling with how to set ambitious plans like that in the absence of a giant global conflict like the Cold War and achieve them. So I guess that is pretty much the whole story as I can tell it in this short time. Again, NASA's done amazing things ever since, and many of them in directly flowing from work during the Apollo program. But we continue to really not have a good understanding or plan of how to send people back to places. The why is a different question, but because it takes so much capital to do this, our institutions, federal and global, are really not set up to do that, and it continues to be a mystery of how humans can expand into space, even if the will was there. And that's something that your generation is going to have to figure out if we are to have a human presence in space. Now, there's some things moving along now that might get there. But the key point about the space race is that it created this incredible capability that was then lost. And that is unique in history. We never before created an ability to travel somewhere, like with a train or with an airplane, and then lost it. And I would leave you with that, to think about that how do we get back there? Was that capability once in history because of the Cold War? Is there a way to convince the world that this is valuable again? I don't know. But it's something I think about because I sure would like to live long enough to see at least humans on the moon, if not other places. And now it's not really a matter of technology, it's a matter of leadership. We know how to build that stuff. We could build it again and better, but we don't have the leadership to do it. And what I would really like to believe is that human beings do not require a giant global Cold War in order to reach that high and to be that ambitious. So I will end on that point, and I'd love to take your questions.
It was really cool to hear about the difficulties and challenges that America faced to develop the space program. Something that it's really cool today is that we're starting to see private companies come into.
Yes.
And I was wondering what you thought about that. Where do you think the future of the privatization?
Sure. Yeah, very good question. So the U.S. government's embrace of private space or commercial space is driven by a couple of things. One, the recognition that the technologies that the U.S. government pioneered and invented are now routinely used by the private sector in communication satellites and lots of other things, and that maybe it makes sense for a private sector entity to take on those functions in a commercial way. And I think that that's absolutely the right way to do it. For example, things like SpaceX and Blue Origin. SpaceX is incredible in a number of ways. Some of the criticisms are that its primary customers of government, but that's okay. Those are the primary space travel customers right now. So I think we're going to continue to see the space technology services being commercialized because it makes sense to do so now because they're not new anymore. They're not so risky, and there's lots of people who know how to do them. So we will continue to see space technology companies grow, but only in many cases, only after governments take the initial risk. So it's still critical to have a vibrant space program, because that's the engine that creates the technologies that can then be commercialized at lower cost, and then the government can get the benefit of that too.
What projects have you worked on recently in your company?
Sure. So I've worked on some small mission concepts. So the way NASA decides what missions to fly, it's a pretty long process, but they go from having hundreds of ideas that have been shown analytically, that have been shown that could be done, and they choose just a few of them. The bureaucratic process by which that's done, I don't think is that interesting for you guys. But it starts with people who are creatively thinking about ways to take scientific measurements around the solar system. So that's the side that I'm on. I'm on my very early side of helping figure out what we can do, what science questions we can answer, and how. So that's what I've worked on mostly in my career. I've never actually worked on an active mission.
At what point do you think humans will reach a Type 3 civilization?
Is that the one where we use all the energy from the star or something?
Yes.
Yeah.
So to expand on that, that's the type 1, 2, 3 civilizations. That's comes from an area of thinking about what would we look for throughout the universe if we were looking for intelligent life. If you were to look for life around the universe that exists, that's at the level of current humans, you might look for radio signals from broadcasts. If you found them emanating from a star, you could probably figure out there's something broadcasting, TV or in that star system. A Type 3 civilization, I think that's where we are now. I think people consider humans a Type 2 civilization. The definition of that is less important. But the Type 3 civilization is a civilization that has figured out how to use all of the energy from its host star. Now, that is an interesting idea, because if you think about it, we get free energy from the sun all the time. If you were to surround the sun with a gigantic spherical solar panel that completely surrounds the sun, in principle, you could use all of the energy that the sun is releasing. Now, this is hypothetical, speculative, nearly science fiction stuff, but you can imagine a sufficiently advanced civilization doing that, because it would be the one way of gathering large amounts of energy. Now that's science. As we talked about, science and engineering, different things. The engineering of such a thing is incredibly hard to imagine. Probably would require more metal than any one planet even has in it. And it would also require something that I've talked about as a major weakness of the current day. It would require leadership on a scale that humans have never, ever shown. Despite access to a universe of limitless resources, humans still choose to fight over small sections of the earth for ideological or economic or whatever reasons. So I don't think humans will ever become a Type 3 civilization, because we're just too stupid. We just keep fighting. We keep fighting when we don't need to fight over. We keep fighting over things we don't need to fight about anymore. And someone who was alive during World War II might say that from a different way, that we haven't learned the lessons of the 20th century at all. And we continue to have global conflict now, albeit at a lower level than World War II. But so we're not going to get to that kind of enlightened future civilization state the way we're going now. And it's going to take everyone in your generation and everybody really to really internalize that and try to change the way human affairs are conducted on a global scale. So thank you for volunteering to solve that problem.
You talked about immeasurable benefits coming off of space exploration, but if the peak of NASA's relevancy was during the time of the Cold War and the space race, where we were actively competing against a foreign nation, what relevancy would you say NASA has during a period of relative peacetime?
That's a great question, and it is continuously raised by critics and supporters alike. So what was accomplished by NASA in the 1960s directly enabled the modern world of technology that we have today. In order to send people to the moon, technological advancements were required in areas far beyond the obvious ones like rockets and fuel and spacesuits. Everything from computer miniaturization to power storage, communication, all of these things required completely new systems to be invented for Apollo. And what you'll see when you guys are out in industry for a while, when you're older, is that often what's created by the products that are developed are not usually revolutionary. They're not usually built from the ground up. They're often slight improvements to something else. And so what that results in sometimes is, let's say, a whole industry that is not really doing anything new because it's able to make money by selling slightly improved versions of things. This is the situation that Elon Musk found the space launch industry in before he started SpaceX. Rather than start from scratch and take everything that was learned from the last 50 years and say, okay, we're going to build something from scratch rather than modify a previous rocket, he decided to start from scratch and build something that's like a third of the cost of the competition. And that is the advantage of what you get when you have a new ambitious space mission, is it creates the urgency of creating totally new technologies that might never have come out of the private sector to solve different problems. So to directly answer your question, I've sort of been dancing around it. The relevance of the space program now is in creating the technologies of the future. In the same way that the relevance, among the relevance, part of the relevance of the 60s in NASA was creating technologies of today. So that's your answer. Actually, let me add a little bit to that. It's impossible to know what you'll get out of something like that, which is one reason why it's so hard to do. If you could say to, Nixon in 1972, hey, this thing that we've been doing, it will create a $500 billion American industry in rocket launches. It will enable a communication satellite network that will connect every human on the planet. It will enable the computer industry that the United States dominates for 50 years by miniaturizing computers to the point where they can be put in your home, and so on. If you could know ahead of time that you were going to get those benefits, it would have been easier to keep Apollo going. But you just don't know that. And so it requires leadership to make ambitious goals and pursue them, not exactly knowing what the benefits will be. And that's where we are now with Mars, by the way. One of the reasons why it's so hard to get NASA to really commit to sending people to Mars, or rather Congress, is those benefits are not obvious. But I can promise you that they will be legion, and they will define the world of the late 20th century. So again, thank you for volunteering to go out and solve that problem.
Wanted to thank you very much. We appreciate it.
My pleasure.
We had a great time seeing you. Thank you again.
Great. Thank you too.
Bye.